Okay, so let me open day one. It's already there. Okay. Okay. So today is the session. Today the second session should be started uh, from the beginning. So we are learning over here related to data engineering. So whoever is already working in a particular project or whoever is trying to join a, lifetime applications or just like this and based on data engineering. So these are the basic steps or maybe those questions and based on the session you can receive some questions from the interviewers and it will help you to answer those kind of stuffs. But if you already have some experience on data, if you are having any doubt while we are doing the classes, no, sometimes I'll be asking you for interacting or any question. If there is any questions in your mind or any doubt at your side, please do stop me and ask me the questions and all so that the things will be more interactive and we can also learn more on that thing. Okay. Okay, give me 1 second. Okay, so today is the introductory session as well based on data. Why we require those kind of data? What are our perspective as a data engineer? What we have to do at the enterprise, and at the end, what the business should need the data. Why we are collecting so much data from different kind of enterprises solution, and after everything has been collected. Why we are what is the main purpose of the data actually? So this kind of stuff you can quickly cover today's session. So basically the plan is there should be one or two introductory session on based on data. Okay. So just like main primary keys for table and all, what is SQL, what is NoSQL, maybe that should cover 2 days. And after that we will be covering the SQL language. Okay, based on the relational database system. It should be mostly 1 week or a bit more. Then we'll be covering Python over here for these courses. And after covering Python, Python is mainly for integrating the data. Maybe if we are working various database management system or working as a tool of ETL, extracting, transforming, loading data between various databases or any flat files. So Python will be playing that particular role as a data engineer over here. So we'll be learning that stuff after that. And after that, the new module should be there as a big data part. That is Hadoop and Spark. It should be just like 1 week. With that, then we'll be covering some cloud computation, especially on AWS system. And at the very end, it should be just like storing the data and in the enterprise, how will work for code repository. It should be especially GitHub. So those are the steps that we will be covering the entire session. Maybe it should be 1 month or a bit more than 1 month. So this is the entire session. We'll be starting today with the data introduction. So first of all, what is data? Data is the collection of information, the particular information that we are fetching from the various source system. So what kind of source system we are fetching the data, that will I'll be coming to this point later, and especially why the data is being used, because describing the system, the source system, their quality, their how much quantity we are getting the things, uh, what are the fact, what are the statistics, what are the different dimensions for that factory or that system, that we are collecting as a form of data. Okay. And then in the next slide, what as a data engineer, what we should do. So we are receiving this kind of data from the source system. So what kind of source system was there? There are various type of, each of the day's practical purpose, just like we are, anyone is working any store. Okay. So store outlet. So their daily basis transaction are the data. So if we are working in a banking system, so daily basis transaction of debit and credit and each of the employees information, the customer, the account holders information, all those kind of stuffs are data. Same kind of things, just like if we are working in a pharmaceutical company, then the all kind of medicines, how the medicines has been distributed between outlets as well as hospitals, how the medical emergencies, how the patients are working, how is their medication. So this kind of stuffs, everything what we are working as a digitally, we are putting record at the computer system. We are filling data at the computer system. Those, by this way we are collecting data. Maybe the system is a mainframe, maybe the system is a .NET, maybe the system is a SAP, maybe it's a simple Excel file. So we are gathering the data and we are pushing the data for the internal calculation. So those kind of calculation or manipulation can be done by the data engineer. So what data engineers basically do, so they're collecting the data from the source system, they manipulate the thing, they analyze, they have the analyzing power from their side, and they're building those kind of source data into meaningful data by which the decision maker, who is the decision maker? Decision maker is from the company itself. Suppose I am owning a banking system, so I need to improve my banking facility, or I need to improve my business actually. I need to revenue more in the next year. So this kind of I what I have to do to doing that particular stuff. So I need to check the statistics. I need to check the pattern of my revenue. I need to check what is the, what reasons are the hidden trends which can improve me for my growth. So this kind of stuffs can help me. If I'm the owner, the data engineer will help me for, to build the relationship from source data to meaningful data. On top of the meaningful data, there are variety of data analysts as well as there are data scientists who can help for the decision owner or decision maker to make the correct decision so that the next year revenue or next quarter's revenue should be having a peak. It's better than the last year. So this is the, overall, or I can say high level perspective of data engineer. Okay. And okay, till now, any doubt from your side? Whatever we just learned. Okay. Hopefully, no. Fine. So those are the variety of sector. If we are just, going to work in a company on top and based on data engineer. So you can if you your client must be of this kind of, maybe it's a banking stuff, it's maybe a commercial one, it's maybe a pharmaceutical one, medical, insurance company. So those are the topmost data engineer client that we can be attached with any client, we can process their data. Okay, so maybe they are using variety of tools, but for analysis or any kind of data processing system. But the main concept is same. We are processing the data to build it a meaningful one, so that the decision owner can take the decision easily. They do not have to sit with pen and paper with their those lots of data. They do not have to do anything from their side. Data engineer will prepare the data in front of them, and they only can take the decision. So that in a cycle, next cycle, the business should be having more revenue. Okay. So going to the next slide. I'm coming to the technical point as of now. The next slide. Okay. So if we just segregate the data segregation is based on these two separation. One is called relational database. Another one is called non-relational database. Okay. So what is the basic difference between these two? Here is a pictorial diagram. You can quickly observe that there is same data. The same data means you can see there is name and email ID, and we can have two rows at the top picture, and the second picture is having the same thing. It's a name and email ID, but the representation of the data is different. So the first one is in tabular format. Okay. And in the tabular format, we have two columns. One is called name and second one is called email. And the second picture, second pictorial diagram, it's having the key value pairs, just like name and email. And this is, if we have anything, any new columns to be added for a particular row, we can quickly add that thing over here. So the main difference is that structural things only. We have a data set we can represent in both way, but based on our business requirement, there should be a data architect. They should have to decide which kind of database system we need to go ahead with that particular requirement from the business side. Especially in our courses, we'll be starting with structural data, the top one in the tabular format, because this is mainly used for analytical purpose. On top of this format, we can put queries to fetch our respective suitable data. And the second one is also required. It's not only for, it's especially not for analytical purpose, but there's various thing. To fetch the data, the second kind of data is much more helpful. There is also non-relational data, just like graph theory. If you can just go ahead with graph theory, just like if we are working in a network system, there is topology. One network to another network, the thing is getting routed and all. The graph theory, what is the minimum distance that anyone can cover? So this kind of data is also called the non-relational database, the graph one. Okay, so we will be especially concerning on SQL topic. For this course, this crash course, and that should be on top one, the tabular format that is called relational database. But at the end, while we'll be learning for the cloud computing part, I'll be quickly covering one day for this non-relational database that is called NoSQL later. But the all over thing, it should be mainly focused on relational database only. Okay, so moving to the next slide, what is relational database and how we can identify, what is the usefulness of that particular thing? Okay, so a relational database, I just put the thing in a brief way. You can quickly go ahead with the points. I will be repeating from myself as well. So relational database is also called Relational Database Management System. In short form, it's RDBMS. And we should be having this kind of courses in our university as well. So, what is the main structural thing or what is the main property for relational database? So you can go to the second point. This table shared information between them, causing a relationship between other tables as well. So in relational database, in a database, we can create multiple tables and we can create relationship between tables. How we can create the relationship, that will be that I'll coming later into later sides, and that should be helpful. And the third point is relational database. The table should be having columns and rows. I think we are aware what is columns. Columns means what are the different kind of fields. Just like in the previous example, we have mail and name. So I need to declare the table structure as a columnar format. That is name and email is two columns for that table. So this is the, entire schema should be created at the earlier for a particular table. Then we need to push the data. Data means the record, that row. Okay. So earlier example, we have two rows. Let me quickly go through. Yeah. The first one and second one, Ram and Bob. So based on two name, we have two email IDs as well. So we have two records for that table, two rows. Okay. So first of all, we need to create the columnar structure for the table. Once this is ready, then we can good to go to push the records one by one. Okay. And in each relational table, there must be not, it's not a must. There should be a primary key. I'll be coming to the point later why we need the primary key and what is the significance of the primary key. Maybe it should be, I'll be covering tomorrow's session. But primary key should be there. What is primary key and what is usefulness? I'll be coming to this point later. And then again, the column can be used in other tables. The primary key can be used in other tables. And that key should be treated as a foreign key from another table. Another table. Okay. That thing I'll be coming quickly in today's session. What is primary key and foreign key? In a brief manner so that there will be no doubt. And in the detailing session, I'll be taking it tomorrow so that we can explain it the more detailed manner. Okay. So coming to the next slide. Okay. So why it's relational database that I told that multiple in a particular database, there may be multiple tables, but they can set up relationship between themselves. Okay. So as per the slide, we can see in the top, there is customer table. This is the customer table. The table name is customer. There is order table, there is address table, there is product table. Okay. In the customer table, we can see there are 4 columns. 4 columns are present. That is customer ID, customer date of birth, order ID, address ID. Order is there, order ID, product ID, date. So between these two table, customer table and order table, they can set relationship between the column order ID. This is the common column between these particular two tables. So in the relational database, we must need that kind of common column. So what is now the foreign key and primary key? In customer table, customer ID is the primary key. Primary key should be a unique one for that particular table. So customer ID cannot be duplicated for that table. And over here in the order table, order ID cannot be duplicated. Okay. So in the order table, order ID is the primary key. But in this table, in customer table, order ID plays the role as a foreign key. So this particular thing is a primary key in another table, but over here in the main customer table, it is working as a foreign key. So the based on the primary key and foreign key, we are setting relationship between multiple tables. So that is the concept. So we need to create multiple tables to establish our business logic. Okay. So based on separate, variety dimensions and all, there are fact dimensions that I'll be covering later. So customer is a dimension, order is a dimension, address is a dimension, product is a dimension. So there are different kind of dimensions, and based on the business purpose, we need to create relationships between the tables so that we can join between tables. Okay, they're foreign based on the foreign key and the primary key. So just I am briefly discussing today all the stuffs. If you are new, then maybe it should be a bit hard, but later in later session that thing will be described in a more detailed manner. But whoever is already have the experience and the basic stuffs, then that thing should be easier. But no need to worry about that. We have later sessions having with detailed uh, discussion on that topic with some hands-on experience as well. Okay. So till now, if you have any doubt, you can quickly ask me.
When we compare order table and product table, product ID will be foreign key for order table, right?
Correct. You are correct.
Okay. Okay.
So over
Thank
here,
you.
order and product. Thanks for the question. First of all, yeah, this kind of introduction is very much helpful, Dipti. So order
Yeah.
and product table. Those are, in later session we can see the joining. There's a joining part in the SQL query. Okay. So in that particular two, we have the relation based on product ID. Product ID is the primary key in the product table. So it should be a duplicate one. Sorry, it should not be a duplicate one in this table. It should be unique one, and each of the product will be representing a product ID. Just like we have a particular toothpaste, just like Colgate, and that should be having product ID one. So one should not be assigned with any more product. So this is the concept. So that product ID should be the primary key for that product. And so if, I mean, maybe when someone is placing order in a particular store, so particular customers, suppose ABC customer, they are ordering product ID 1. That means he is purchasing the toothpaste Colgate. Okay. So this is the thing. I mean, in order table, we will not be placing the product name there. No, instead of putting Colgate, we are pushing only 1. So this kind of thing, why we are passing this ID part, I mean, that should be taking less space. Uh, so this kind of stuff I'll be covering later. Why we are designing in this way? Instead of putting product ID, you can also put product directly. So that thing I'll be covering tomorrow's session. Why we are creating this kind of relational part. Instead of doing that, we can create only one table, one single table, having all the columns. Do not put the order ID. Instead of that, we can directly put order number. Why you are putting address ID? We can put everything in a single table, address ID, line, pin code, everything in a single table. But this should be a big mess, and why we should not be using that one for analytical purpose. And what is the main fundamental stuffs I'll be covering to tomorrow's session. But yeah, you are correct for that order and product stuffs. Okay, so going to the next slide. Okay, so on top of RDBMS, when we'll be analyzing the thing, when we are traversing the data, I mean, it should not be a 2 or 3 records when we are working in an enterprise solution or any practical business scenario. For that, I mean, that kind of, I mean, when we'll be working in a live project, in a particular tables, there should be millions of records. Okay, millions of billions. So I cannot check on one particular record quickly from my side. So for that thing, we need to know what is SQL. That is a language, a programming language. We can also say structured query language. So SQL is useful for traversing the data, to check the data, to validate the data on top of relational database. So those tabular kind of data, we cannot, I mean, we can quickly check by this SQL query. So those kind of query we need to write on top of the database. So if you are new with the SQL, don't be worried. I mean, there will be detailed session, maybe 1 week or more than 1 week, to write this language by your own. It's very simple. If you just go ahead with single go, can check, I mean, how is easy it is, and how we can quickly check the data by this query. Okay. And based on this query, we can manipulate the data as well. We can join between multiple tables. We can convert the table in a pivot one. We can order based on some data. We can sort the data in a particular table. So everything can be controlled by this SQL, structured query language. So maybe the day after tomorrow, this should be our main learning thing, the language. And in each of the table, we can, on top of the table, we can use that language to have more knowledge on that thing. Okay. So basically SQL is the tool to check the data from a particular table quickly, especially for relational database. Okay. Now, what is non-relational database? Today, I'm just covering it a basic way, high level thing. What is it? Maybe if you are facing any interview questions, you can just answer it quickly. But if you need to know some more thing, just go ahead with the difference between relational database and non-relational database. The same thing, SQL versus NoSQL. What is the difference? Just check it. If there is any doubt, you can ask me in tomorrow's session. And what is the usefulness, and which scenario we should use that thing? Which scenario we use relational database, and which scenario we should use NoSQL and, I mean, non-relational database. So just check it quickly from your side. Tomorrow we can quickly discuss if there is any doubt on that one. But what is non-relational database? I just mentioned in the previous slides. So it should be having key value pair, and it should not be using any tabular structure. What we are using in the SQL side, no tables, no fields, no columns should be there, no structured concept. So For SQL side, we need to create the table first. That means we need to create the table with the columnar format. The table structure is been defined earlier. Then we can insert the row one by one. But in NoSQL, no such concept is there. We can, there is no such row column concept. So we can enter any kind of field at any time. And entry of a field or deleting a field is very much simple over here. Okay. So how it looks like actually. So this is a JSON format. I just picked this snippet. So in the JSON format, we can see the key value pair is there. First, the first option, this is the key and this is the value. Okay. And in this format, we can quickly understand the hierarchical way. We can check over here. Address is the main key over here. And inside there, again, we are putting a hierarchical structure. So we are drilling down inside the address field. There are several kind of addresses we can put, and we can closing the main key over here. The same like, by the same way we can put the hierarchical manner in one or two hierarchy. It's up to our wish. We can declare in this way. It's like phone number over here, children they are mentioning over here. It's a single one, but the same thing we can declare in NoSQL manner. So it's not maintaining the structural way, but it's having the key value theory. So if we are aware of the dictionary data type, or just like list, any kind of array, so those are non-relational database. Later we can check when we will be learning Python. So we'll be transforming the data from dictionary to SQL one. The relational database one. So how to convert between the database and how to work on that one. Okay. So my request from to you, quickly check what is the difference between SQL and NoSQL. You can get more points from our side. Then we can quickly discuss. And if there is any doubt, we can quickly discuss. Obviously, tomorrow session. What is the main difference? Okay. So I think that's all from the non-SQL side. I'll not be covering much more in detailing way for NoSQL. So everything should be there in the next sessions onward, especially on SQL, the structured one, the tables, how to create the tables, how to insert the rows, how to update the rows, how to update the table structure. So this kind of stuff we can quickly discuss maybe tomorrow or the day after tomorrow. So in this slide, we can see a data representation in charts and graphs. The thing I just want to convey you at the earlier. So we are receiving the source data. We are creating this thing and in a good shape so that business can understand the thing. Even we can map the particular table in a graph. Okay, the same table is converted into a line chart, you can see. And if we are converting into line chart, then it's, the decision maker, it should be a huge, time saving thing. They can easily check whether their business is fine, the revenue is fine, the particular slope, they will be checking the slope. They can compare the thing from the previous one. Actually, though there are very few records, there is 8 to 9 records over here. But in a business scenario, there should be lots of records actually. So this kind of stuff, the visualizing on that top of the graphs and charts, that should be very much helpful for the decision maker to take the decision quickly at their side. Okay. So this kind of data manipulation will be providing to the business user or the decision maker so that they can take the decision easily from their side. So this is the main work the data engineer. Okay, so just I'll be giving you some basic examples on top of Excel. Okay, Excel is also a relational database. Microsoft Excel, or you can also go ahead with Microsoft Access. If you have the Office kit is being installed in your machine, you can find the Microsoft Access is there. There you can also maintain a relational database management system. Okay. So I already created a relational database over here based on some product. Let me know if the screen is very low. Let me zoom it quickly. Okay. So I created a relational database quickly. There are four columns for product. And a product, the price is there, discount is there, final price is there. Okay. So just like it's price minus discount should be the final price. Here is the product name. So in that particular table, the tabular structure is having four columns and three particular records. Okay. So I can just convert the same thing in particular chart. I'm just converting into a bar chart. Okay. So there is, I mean, different we can, there is different, I mean, visualization thing, just like I'm choosing this one. So if I choose the thing, it is converting the entire stuffs in a particular chart. But this is not a good one because I want this relation in a single way. I mean, the thing should be group by. Here the group by thing is on top of price, then discount, then final price. And over at the below, you can see cap, board, and pen drive. Blue color is the cap, board, and pen drive. But this is not a meaningful way to describe the data. If I'm the business owner, I'll be saying this is not the good way. Why we are grouping by the data on top of price? Instead of doing that, we can take the whole thing as a cap, the first one, and the three bars should be price, discount, and final price. That should be helpful from my side. So this kind of meaningful data, we have that understanding or we have that knowledge among ourselves as a data engineer. And if we are not understanding, if we can learn the thing from the business, we can quickly understand the thing at our side and we can quickly convert the thing. So we should have this capability. Now I'll be transforming the same graph and you can see how meaningful it is. So this kind of thing will be converted into cap. I mean, the product name, this pair. Okay. And each of the bars should be each thing, price, discount, final price. So not of this kind of stuff. This is also a meaningful one, but this is less helpful. Let me convert the thing and now you can see how much helpful it is. Okay, how to do that thing? So there's advanced option. I can choose the second one. Now you can see how meaningful it is. So the first set of the thing is cap. Over here I can see the blue color. I mean, now the bar is showing these three columns. The blue one is the price, the orange one is the discount, and this is the final price. And how it can be the meaningful one. We can subtracting that particular thing from this tip, and we can get this tip. It's a bit low. The same thing over here. This thing I'm just subtracting from this, and I'm getting the final price as this. So this is much more helpful for each of the product. So this kind of I'm just trying to convey the same thing. I mean, the meaningful one we need to represent to our customer. Even if it's not the meaningful one, they can ask us or they can tell us for reverting it back with the other one or change it to this one. So this kind of instruction we can get and we have to work accordingly. And this is the entire stuff. I mean, a basic way I'm just trying to give you the example. Hopefully you can understand the thing. So this kind of stuffs we have to do as a data engineer, but not in this way. There may be lots of records, not 3-4 records. There may be millions or billions of records. And on top of that, we need to create those kind of charts, graphs, and it should not be Excel actually. Excel cannot store this many data. If there is less data, sometimes we can check they are sending the CSV file, text file, or this kind of Excel as well. But this kind of graph or manipulation, we should not be doing in the Excel. As this is a small example, I just provide you the example. So for this kind of visualization, there are variety of tools actually. The tool name I just provided over here. That is Tableau, Click, Power BI, Cognos. So whatever I just showed you in the Excel with variety of charts, graphs, the same kind of thing will be doable at the enterprise by these particular tools. Okay, and they can able to manipulate the data. Uh, okay, so let's see what are the next topics. Yeah, as of now, today we have covered uh, the basic steps. What is the main fundamental steps from the data engineer side? What we need to do actually in front of, how we need to prepare the thing that should be coming later, but why we should be requiring that stuff just we covered, and what is relational database and non-relational database. That is the main thing just we covered today. So tomorrow onwards, we'll be going ahead with the relational database only, the data with the tabular format, with some basic concept. And then when it's over, then we can quickly go ahead with the SQL part, that structured query language, by which we can query on top of relational database, and we can manipulate the data as per our own wish. Okay. So from today's session, is there any doubt from anyone? Okay, hopefully no. But if there is any doubt, you can quickly ask me. And from my side, I'll be requesting you to check what is the difference between SQL and NoSQL. Just this difference. You can get multiple points. If you are not able to understand any points, then we can quickly discuss the same thing in tomorrow's session at the beginning. Okay. And tomorrow we'll be going ahead with detailing manner. What is, between the relational database, why you are using foreign key, primary key, and what are the separate kind of keys are there as well as why we are using the normalization part in each of the table. So normalization, denormalization, and several concept on RDBMS as well, that is relational database. And we will be quickly cover how to install a software for the SQL query to create the database. The software will be taking MySQL, but that thing should be gradually been introduced in later session, maybe tomorrow, day after tomorrow, one by one. And but my request is, if there is any doubt or any stuck point, please do ask, or just help with your doubts. That should be also helpful for me. If anything is new, then I can also interact with that one, and I'll be happy to help. Okay. So that's all from today's session. Let's continue from tomorrow's session onwards. Okay. Okay, then. Thank you, everyone. Bye bye. Have a great day.
Thank you.
Thank you.